Welcome to this video on locating roots. Now, the root of a function is a value of x for which f of x equals 0. You would have done this when you were solving quadratics and things like that, in GCSE level. It will also be, where the graph of f of x, y equals f of x, crosses the x-axis. Okay, the points it crosses, these are the roots. Now, if the function, like f of x, is continuous on the interval between like a and b, and then they have f of a, f of b of opposite signs, then there's at least one root. So what I mean by that is if I had a graph that looks like this, and then what I do is I find the value of x here, and it's going to produce a negative value for f of x or y, and then I find a value of x here, and it's going to produce a positive value for f of x or y. Now that change in sign, so that change in sign from here to here, negative to positive, will indicate at least one root. Okay, but only if this is continuous, there's no breaks in it, and it's at least one root, because depending how far apart your values of x are, there actually could be 2 roots or 3 roots within this section. Okay, more likely like 3 roots, an odd number because of the change in sign. Does that make sense? So that's like a root, and that's effectively how we're going to find it. We're going to look at values of x, and when the f of x is positive or the f of x is negative, to indicate the roots. So these would be like our a and our b. But I have to be careful because, I'm going to show you on this one. But if I take my a and b as here, I wouldn't really do it this far apart. It's visual, but if the numbers are close, a and b here, both a and b indicate a negative value, but there is 2 roots between them. Okay, so I do have to be careful with the sign change. It's not always that there's exactly one root, and not having a sign change doesn't mean there's definitely no roots. Also, when my graph isn't continuous, so I've got, like 1 over x graph here, something like that. If I take my value of a here is positive, and my value of b here is negative, and that will give me a sign change, but there's obviously no root in between them, because in between them is actually an asymptote. Okay, so you do have to be careful with this. It doesn't work for every scenario. Now, let's have a look at an example. So here we have a function, a cubic. F of x is 20x cubed plus 3x squared minus 12x plus 1. And it looks roughly like this. You have to forgive my drawing. You can always put it into Desmos to see the exact graph, Now, student observes that f of 0 and f of 0.7 are both positive. So f of 0, just slightly positive there, and I'm guessing f of 0.7 is actually the other side of this, and it will be positive up there. Explain by reference to the diagram why the student is incorrect. I'll just move that one over a little bit so it makes a little bit more sense. Right, why is he or she incorrect? The diagram shows that there could be 2 roots within that interval, here and here. So that's all we need to do for this. I'll answer in red. So the diagram shows that there could be two roots in the interval 0 to 0.7. So that's all there is. There's two potential roots. I mean, there are exactly two roots. So we should, but when we're doing this, you know, we do use could be, at least, words like that, not give a definitive answer. Now, B says calculate f of 0.3 and use your answer to explain why there are at least two roots in the interval 0 to 0.7. Okay, so f of 0, we know this is positive, so we don't have to calculate it, but I will calculate it for you. Because if x is 0, that's 0, that's 0, that's 0, it's just 1. So f of 0 is 1, which is greater than 0. It's positive. Now let's do f of 0.3. And that is minus 1.79, which is obviously below 0. And then the other value that we had was 0.7, which we know is positive, but I will calculate it for this. And that's 0.93, and it's positive. But you could just state this is positive and this one's positive because it was given in the question. Okay, so now we can go ahead and look at the sign changes. So there's a sign change between 0 and 0.3. So there's potentially at least one root there. And then there's a sign change between 0.3 and 0.7. So there is at least one root there. So that's what we can say. There, oh, sorry, I have a pen on. There is a sign change between 0 and 0.3 and between 0.3 and 0.7. So there are at least two roots in the interval 0 and 0.7. Okay, so I'm just writing it as an inequality interval instead of the other one up here. Okay, and that's the kind of thing that we're just looking at for this, just the introduction to locating roots. Okay, nothing too difficult about it. I'll give you a couple of questions just to have a go at yourself, but then we'll get on to the next video. But before we get stuck into some questions, I'll just show you one more example with how we verify a root. So I've taken the same function, and the f of x has a root called alpha. Verify that alpha equals 0.652 to correct the 3 decimal places. So how we do that is we are looking for a sign change, and we're going to substitute in two values either side of 0.652 that basically should round to 0.652. So for example, 0.6515. So I'm going to the 4th decimal place, and if I rounded this to 3 decimal places, it'd be 0.652. Okay, So that's what one way I'm going to do it, and then I need to go the other side of 652. Now this should be 249999999 just to round down to 0.652. But because, you know, in maths 0.6524999999 recurring will be basically 0.6525, then that's what we're going to use. I know that technically it doesn't round down to 0.652, but just like when we looked at in GCSE and you looked at upper limits and lower limits and things of flat areas and stuff like that, you always go to the 5, even though technically it'll be a 4 and then 9 recurring afterwards. Okay, so now I'm just going to put this into my calculator, and I get for this one minus 0.01403, and then it carries on. So this one is less than 0. And this one is 0.003387 8 and carries on. So this one is positive. So that's what we've got now. So we can say change a sign. So at least one root. Or in this case, because we were given the root, maybe change the sign implies root. And that will be enough then to verify the root. Okay, just 2 questions to have a go at this. Very straightforward. Pause the video now. So part A, we've got to show that when that equals 0, blah, blah, right, f of 2.1, so it's 5 plus 2.1 squared minus 2.1 cubed, and that equals 0.149. So my f of 2.1 is greater than 0. And then f of 2.2, so it's 5 plus 2.2 squared minus 2.2 cubed, and that equals minus 0.808. So f of 2.2 is negative. Okay, so sign change implies at least one root. Now B, we need to verify this. 4 decimal places, so we need to go to 5 decimal places. So f of 2.11625 and f of 2.11635. So go into that 5th decimal place, and then like in that 5th decimal place, 5 up and 5 down. That's what we're looking at. So the first one is 0.000858,677, so on. So that is positive. And it says minus 0.4 zeros, and then 616,61679, and it's negative. Okay, so sign change implies root. So that's that one. Let's move on to the next one, although it will be pretty much the same. So I won't speak I'll forward it quite quickly so you can just check your values. I hope you found this video useful. Start of chapter 3. But you know, it is quite straightforward, so let's get on to the next one. Don't forget to like, subscribe and all that jazz. Comment down below if you find any mistakes or anything. Yeah, I'll speak to you soon.